So schools are closed for most pupils, but they're still open for pupils of key workers. So I'm going into school today to supervise some key workers, and whilst I'm in there, I'm going to do some tests for gases. The 3 gases you need to be able to test for in your exam are oxygen, carbon dioxide and hydrogen. So I'm going to do those 3 tests today. You'll need to remember what you do and what you expect to see for each test.
Recording.
In this experiment, we're going to be testing for carbon dioxide gas, and we do that using a solution called limewater. Now, limewater looks just like tap water to begin with. It is colourless and clear and looks just like tap water. Now, there's carbon dioxide in my breath, so I'm going to put a paper straw into my limewater and I'm going to blow into it, and that's going to blow carbon dioxide gas into the limewater. When the carbon dioxide goes into the limewater, you can see the limewater goes milky, and that's because we've formed an insoluble precipitate, calcium carbonate. Now, the biggest misconception, the biggest error I see in answering questions on this is an exam question will say, how do you test for carbon dioxide gas? And people say, blow into limewater. The only reason I blew into limewater is because I was testing the gases that I was exhaling to see if they contain carbon dioxide. In an exam question, you always need to say what you do and what you'd expect to see. So to test for carbon dioxide gas, you bubble the gas through limewater, and if it turns milky, then there's carbon dioxide in that gas.
Action!
In this test, we're going to test for oxygen gas. First of all, I'm going to do a chemical reaction that produces oxygen gas. I'm going to start with hydrogen peroxide, H2O2, and I'm going to add a catalyst to it, manganese dioxide, and that's going to cause the H2O2 to break down into H2O water and O2 oxygen gas. So this will start to fizz and produce oxygen gas. Now, to test for oxygen gas, you don't need any special chemicals. You simply need a splint that you've put on fire and then blown out so that it's still hot and it's glowing. So to start off with, I will make my oxygen gas by putting my catalyst in. So this is a decomposition of H2O2, breaks down into water and oxygen. Now I'm going to set my splint on fire. But I don't want a splint that's on fire, I want a glowing splint, so blow it out and it relights when you put it into oxygen gas. Relights in oxygen gas. Now this is logical. If your campfire starts to go out, you blow on it and your campfire comes back to life again. That's because you're blowing more oxygen onto it. So if you have something that's hot, that's glowing, a fire that's going out, and you put it into oxygen gas, it relights. So whenever you're talking about a chemical test for a gas, you need to say what you're going to do and what you expect to see. For oxygen gas, you add a glowing splint, and what you expect to see is the glowing splint will relight.
Action.
In this test, we're going to be testing for hydrogen gas. So first of all, I need to produce some hydrogen gas, and I'm going to do that with a reaction between hydrochloric acid and magnesium metal. Now, acids and pure metals always produce a salt and hydrogen gas. So if I pour some acid in first, once I drop my piece of magnesium in, it's going to start to fizz, and that fizzing is going to be bubbles of hydrogen gas being produced. Now, this is similar to the test for oxygen, except this time I want a lit splint, not a glowing splint, but an actual lit splint, one that's on fire. And I'm going to pop that into the gas that is produced between the reaction between the metal and the acid. And if it's hydrogen gas, it should give a squeaky pop. So I pop my magnesium in. You can see it starts to fizz. Bubbles as the gas is being produced. I'll light my splint. I'll leave it lit, and I'll pop that in with the gas that's being produced. Hopefully you heard that was a squeaky pop. I'll give it a couple of seconds, wait for some more hydrogen gas to build up, and see if we can get another squeaky pop. Okay, and that shows me, that squeaky pop shows me that it is hydrogen gas, that is the gas that's being produced. Now the biggest error I see in people's answering this question is the question will say, how do you test for hydrogen gas? And people say, squeaky pop test. That's not going to get you the marks, because again, you need to say what you're going to do and what you'd expect to see for hydrogen. So what do? You add a lit splint, a flame, a splint that's on fire. What do you expect to see? You expect to see, or expect to observe, a squeaky pop if there's hydrogen gas present. Yeah. Now when we test for hydrogen gas, and we put our lit splint and we get that squeaky pop, that's actually a tiny little explosion that's happening in the test tube. The reaction is between the hydrogen gas that we produced and oxygen in the air, and they react together to form water, and it gives out lots of energy that we hear as a squeaky pop. Now you can do that on a slightly larger scale. What I've got in this balloon is hydrogen gas again and a little bit of oxygen gas, and I'm going to do the same experiment but on a slightly bigger scale. I'm going to take a splint, set it on fire, so I have a lit splint, put the lit splint underneath the balloon to give it some energy, and then we should get our hydrogen and oxygen react to give a bigger version of that squeaky pop that we heard earlier. So I set my splint on fire just like I did in the last test, and this time I'll turn the lights out. And on a slightly bigger scale, we've got a much bigger version of the squeaky pop test. Now that same reaction between hydrogen and oxygen gives out so much energy, it can actually be used as rocket fuel to power rockets which go up to space as well, but they control that experiment, so all the energy goes in one direction and gives them the boost to go up. So I light my splint just the same again, so this is a lit splint, pop it underneath the balloon to heat up the hydrogen. Oh my gosh. Should I do that again?
Yeah.
Have a go at a few questions, pause the video, and then unpause to see the answers.